we have to use the substitution in order to show this particular integral over here. Okay, let's start. See, if you want to use substitution, you can split the question into three parts: the front part and the middle part and the back part. So if you want to change the back part, usually you have to do differentiation. If you want to change the front part, you have to use substitution. And the middle part is just some algebraic manipulation. So that's how the idea goes on. So I'm going to start with the back part because it's always easy. So u is equal to tangent x. This is the substitution form given. So I'm going to do du dx. So you can use your MF19 and you know the answer is secant squared. So can you see I am making the dx as a subject. So I'm getting du over secant squared x, done. Next I'm going to go and change my front part where I'm going to use substitution, where if my x is equal to 0, okay, why is my x equal to 0? So you can observe at your question here. Look at all the variables. It is integrated with respect to x. So your question is written in terms of your x. So the limit is definitely an x value over here. So if x is equal to 0, my u is going to be what? How do I know this is given? So you just substitute tangent 0. So it's a 0. If my x is equal to pi over 4, then your u is equal to tangent pi over 4, which is equal to 1. So I'm done. From x, I managed to change everything into a u now. Okay. Now let's go to the middle part. So what is happening in the middle part? They are giving me that tangent x. And then there is an n up here. What is the meaning of this? This is just tangent x to the power of n. I'm sure you are aware of this. So what is tangent x? You use this and you substitute. You get u to the power of n. Next, let's do the same for the other term. Tangent x to the power of n plus 2. So I'm going to get u to the power of n plus 2. Now I have to add both of them. So how are we going to add this? What term is common now? What looks common in both? U to the power of n. So you use index law and then you can rewrite like this. Okay, so I can factorize u to the power of n now. So I get u to the power of 2 plus by 1. Okay, done. So it looks presentable so far. Let's go and change everything. So here I'm getting u to the power of 1 and u to the power of 0. The middle part becomes u to the power of n, u to the power of 2 plus 1. And what is your dx? So look at your dx and you substitute du over secant squared x. What is not beautiful at this point? See, when you are trying to substitute, you need to change all your variable from x into u. Okay, this is already a u, already a u, already u, already an u, already an u. But this is still an x. So you have to find a way to change secant squared x to be written in terms of u. So what we can do, we can go to MF19 and you look here, you have a formula which connects. Secant squared theta is actually equal to 1 plus tangent squared theta. So we use this and we try to change now. Secant squared x is equal to 1 plus tangent squared x. You change the variable to x, the original variable in the question. So 1 plus u squared. How do I do this? I just take this and I go and substitute here. Okay. So can you see your secant squared x is now 1 plus u squared. And you can cancel the terms which will give you u to the power of n. Du, u limit is 1 and 0. Done. Now you can integrate. But this integration can be challenging for underperformers because the variable is no longer x. It's not a common variable. It is written in terms of u and sometimes it can confuse you. If you are such student, what you can do, you just scribble using your pencil. Always write u is my variable. So you just change it to something you are comfortable with, like a x, so that the question looks better. Like this. Can you see? So immediately you know the answer is going to be x to the power of n plus 1 divided by n plus 1. So you apply the same concept. So you get u to the power of n plus 1 divided by n plus 1. Now your limits are 1 and 0. Substitute 1 over n plus 1. Your variable is the u. Okay. Do not wrongly substitute into the n. Okay, minus 0 to the power of n plus 1 divided by n plus 1. I think you already know you will get 1 over n plus 1 as your final solution. Done. We already show this. So let's move on to the second part. The second part of the question say hence. It means I have to use the information from the first part and find the exact value of this integral. So what is the variable in my integral? Everything is x. All written in terms of x. Correct? You know that this x The limits are from 0 to pi over 4. How do I do it? And what is the problem I'm facing? The only problem is I no longer have tangent, but I have secant squared x. Okay, and I do not have the n, but I have a power now. My power is given as 2 here. So what can I do to convert this? First is I have to try to change it into tangent. So that is easy for you because you already have the MF19. Secant squared x is equal to 1 plus tangent squared x. So what is secant to the power of 4x? If you want, you can write it as 1 plus tangent squared x and then you can square them. Or you can factorize this from the beginning to make your life easier. Secant squared x, let's factorize, minus 1, the dx stays the same, the limits are all the same. Okay, what is secant squared x now? See, secant squared x, secant squared x. So you can start substituting. 1 plus tangent squared x, done. The first one is done. Now I'm going to do for the next one. Secant squared x minus 1. Secant squared x minus 1 is just tangent squared x dx. An expansion will help you to get the form in the part 1. I expand. I think this should be quite manageable for you. Now let's compare. Okay, what is the power that I'm having? The power that I'm having here is 2 and 4. Okay, look at this. This is n plus 2 and this is n. It's a extra 2 plus 2, correct? So, if my n value here is 2, here I'm going to get a 4. So, what is this? That is just 1 over 2 plus 1, which is 1 over 3. Okay, you can check your solution by inputting this into the calculator in case you are not very comfortable or confident. Okay, the next part of the question. Now this looks a little bit better because everything is written in terms of tangent. And you know already the pattern. If this is a 3, you will get a 5 here. If it is a 4, then you will get a 6 here. If this is a 5, you will get a 7 here. If this is a 6, you will get a 8 here. I think you should be able to see this pattern by now. Okay, now using this, let's check again. Is my variable all in x? Yes. And the limit is not changing. It's same like my question. So once you have checked everything, we can go and solve bit by bit. Okay, so if I have a power of 3, I know I will get a 5 so that it matches with this. Can you see that? Okay, let's write. So tangent 3x, it will get paired with 5 power x. But what is the problem that I'm facing? The problem I'm facing here is I have a 5 here. Although I have a 5 here, for the next term here, power of 7, I'm also having a coefficient of a 5 here, which does not exist here. So the question is helping you to see the idea of factorization. So what we do, since we already use 1, we put the remaining 4 over here. Okay, so you know what is the answer for this. This is just 1 over 3 plus 1. Let's say I want to balance it. I'm just going to take 4 from here for tangent to the power of 7x. Only by doing this, I can factorize them and quickly see the pattern in the part 1. Correct? You know that, now this becomes 4, 1 over what? What is the n now? What is the n now? I have a 5 and a 7. So my n has to be 5 plus by 1. Okay, well, how much more do I have left here? 1 of tangent to the power of 7x, which I can pair it with tangent to the power of 9x. So all of this is going to give me 1 over 7 plus 1. So finally, we just add them all. 1 over 8 plus 4 over 6, which is 2 over 3 plus 1 over 4. Balancing this will give you 25 over 24.